So as we are graphing logarithmic functions, we first want to remind ourselves about logs and exponents. So we're going to write this down. Logs and exponents are inverses. Okay, so last block, I took you down memory lane to first grade, adding and subtracting. Those are inverse operations. They undo each other. So logs and exponents, those are inverse functions. They undo each other. And so as we go to graph this logarithmic function, we want to graph its exponential partner, because we know how to do that already, and then we'll be able to graph the log very easily. Okay, so we're going to start with the function f of x is equal to 3 to the x power. So that's an exponential function, and we know how to graph it. In fact, I believe we graphed that exact one last block. But I'm going to start with a table of values, x and f of x. Recalling that graphing an exponential, one good x to plug in is 0, because we know that any number except 0 raised to the 0 power is 1. Another good number to plug in for x is 1, because 3 to the first power is 3. Then we probably want to see what's happening if x is negative. So if I plug in a negative 1, if I have 3 to the negative 1 power, if you'll remember from last time, that's going to be 1 over 3 to the first power, so it's going to be 1/3. And then, just to see my shape a little bit better, I'm going to plug in a 2, and 3 squared is 9. Alright, so here in the middle of my page, I'm going to draw a nice big coordinate plane. And I'm going to graph these points. So I have 0, 1, and I have 1, 3, and I have 2, 9, and then at negative 1, I'm only up 1/3. And so then based on what we've done before, this is going to be an exponential curve like this. Alright, and then let's go ahead and talk about some key features of this curve, because we did this last time. So the domain for this exponential function, we can see that there is no restriction on the domain. The domain is going to be from negative infinity up to infinity. Then the range. Now when we go to do the range, that's when we will notice that there is an asymptote here. So I'm going to draw that in a different color. So this exponential function has a horizontal asymptote. And the equation for that asymptote is y equals 0. And the presence of that asymptote is then related to our range. So our graph is never going to get down to 0. It's going to approach 0. It's going to get really close to 0, but it's not going to touch 0 or go below 0. So that means my range is parentheses 0 to infinity. Parentheses indicating I'm getting as close to 0 as I can, but I'm not touching it. And then another important feature of this graph is our y-intercept. Our y-intercept is right there at the point 0, 1. And we might note that this graph has no x-intercept. Alright, so now we're going to remember that when we have inverse functions, what happens to the input and output values in the table for the inverse? They're switched, right? So, my inverse function, I'm going to use a red pen for that one. And I'm just going to slide over here a little bit. So my inverse function, f inverse of x, is log base 3 of x. And so I'm going to have x, and then I'm going to have f inverse of x. And so I'm going to zoom out for just a bit. So all I'm going to do is take these entries in my exponential table and flip them. So instead of 0, 1, I'm going to have 1, 0. Instead of 1, 3, it's going to be 3, 1. Instead of negative 1, 1/3, it'll be 1/3, negative 1. And instead of 2, 9, it's going to be 9, 2. Alright, and then I'm going to go ahead and plot these 4 points on the graph. So I've got 1, 0 right there. I've got 3, 1. Then I've got 1/3 is negative 1. Then I got to go all the way out to 9. At 9, 2. And so this logarithmic function is going to curve like so. So this is my f inverse of x, which equals log base 3 of x. So now let's analyze the features of this logarithmic curve, which for me is red. So the domain here, take a look. Do I have any negative x output? If negative x is my input, do I get anything out for negative x's? No, there's nothing over here, right? So I actually have a vertical asymptote. Do you see that? It's on the x-axis. So this function has a vertical asymptote. And the equation of that line is x equals 0. And so that vertical asymptote helps define my domain. So my domain is from 0 to infinity. And if I want to look at the range for this function, well, my range is going all the way from negative infinity, and then it's going to continue up to positive infinity. Right? It's not getting up to positive infinity anytime soon, but it's going to get up there. So negative infinity to positive infinity. And then notice that this graph does not have a y-intercept because there's an asymptote, but this graph does have an x-intercept. and my x-intercept is at 1, 0. Alright, so now I'm going to grab a highlighter here. Do you see that my domain on my exponential is the same as the range on my logarithmic? Right? Because on inverses, the domain and the range are going to trade. And then if I take a different color highlighter, notice that the range of my exponential is the same as the domain for my logarithmic. Then look at our intercepts. Y-intercept 0, 1, x-intercept 1, 0. See that connection? Alright, there's one more thing about these graphs. Do you remember that inverses always reflect over a certain line? They do. Does anybody remember what that line is? It's the line y equals x. So if I come in here and I go through 1, 1, and 2, 2, and 3, 3, everywhere that y and x are equal to each other, 0, 0, negative 1. So this is my line y equals x. Inverses always reflect over that line. So if I picture the purple graph and fold over this line, can you picture how it will lie on top of the red graph? Inverses reflect, so let's just write that down at the bottom. Inverses reflect over the line y equals x. Very important. Alright, I need you to grab a calculator, and I want to show you something about inputting a log. Like when we graph by hand, we really want to focus on the exponential curve and the inverse aspect, but you can graph a log on your calculator. So if you go to y equals and clear out whatever's in there, and this math button, right? So it's right underneath the green alpha. If you press math, and you've already got 9 things there, but scroll on down past those 9 to the capital letter A. You see the capital letter A says log base. That's the one you want. You hit enter. And so for the example we just did, our base was 3. Could put a 3 there and put an X here. And then if I graph it, and there we have a graph similar to what we had. Now, if I go to my table, I'm going to show you something. Right? All these negative values say error, right? And then I have the point 1, 0. But it looks like I don't have any negative answers. But I know when I did it by hand that it went down to the negatives. Let's look back on our paper for just a minute. Do you see that all of the negative outputs occur between 0 and 1? So they're not showing up on my table right now because I don't have any entries in between 0 and 1. So if I go to table set, which is second window, and I make my table start at 0, but I make it count by 0.1, so I get some decimal entries in there. And then I go to table, and now I can see, yes, I do get some negative answers. Right? So that's why I want you to use your calculator, but I also want you to realize that your calculator only gives you the view that you ask it for. So sometimes something might not look right on the calculator because you may need to adjust the table setting or the window or something like that. All right, so now you're going to